Imagine a landscape swallowing itself whole, giant craters appearing seemingly overnight in the Siberian permafrost. This isn't science fiction. It's a terrifying glimpse into our climate-changed future. These mysterious sinkholes are more than just geological oddities. They're a chilling warning. What are they telling us, and what will happen next? Giant sinkholes appearing across the Siberian permafrost are a startling visual representation of climate change. These craters, often hundreds of feet wide and dozens deep, are irregularly shaped and scattered across the region. Their emergence, first noted in recent decades, has increased in frequency, prompting intense scientific investigation. Initial theories ranging from meteorite impacts to underground explosions proved inaccurate. The true cause, as we now understand, is far more complex and alarming, directly linked to the thawing of permafrost and the resulting instability of the land. Siberia's permafrost, a layer of permanently frozen soil, is crucial to the region's ecosystem. Composed of ice, soil, and rock, it underpins the landscape. However, climate change is causing this permafrost to thaw, leading to instability. One result is the formation of pingos, mounds of earth formed by the buildup of pressurized groundwater beneath the thawing permafrost. When the ice within a pingo melts, the ground above collapses, creating a dramatic sinkhole. This process involves complex hydrological changes as thawing permafrost releases groundwater, altering pressure and leading to the eventual catastrophic collapse. The resulting sinkholes are not only visually striking but also represent a significant environmental threat. The thawing permafrost releases trapped methane, a potent greenhouse gas, accelerating climate change in a dangerous feedback loop. This destabilizes infrastructure, threatening Siberian communities and potentially causing significant damage. Furthermore, ecosystem disruption is extensive, leading to biodiversity loss as habitats are destroyed and altered. The resulting changes cascade through the food web, impacting local wildlife and potentially disrupting regional ecological balance. This environmental damage underscores the urgent need for effective mitigation strategies. Climate models predict a significant increase in sinkhole formation as permafrost thaw accelerates. Mitigation strategies must focus on early warning systems, utilizing satellite imagery and ground-based sensors to detect pingo formation. Developing advanced monitoring technologies capable of operating in harsh Siberian conditions is crucial. This includes deploying autonomous drones and sensor networks for remote data collection. Furthermore, research into stabilizing permafrost, perhaps through techniques like artificial ground freezing, needs substantial investment. International collaboration is essential to share data, resources, and best practices for effective mitigation, and to build a comprehensive understanding of this evolving threat. Siberian sinkholes aren't unique. Similar phenomena, though perhaps on a smaller scale, occur in other permafrost regions like the Arctic and Alaska. These areas, all vulnerable to thawing permafrost, face the same risk of ground collapse and associated environmental damage. The Siberian sinkholes, however, serve as a stark visual representation of climate change's global impact. Their dramatic appearance highlights the urgency for international cooperation and strengthened climate action. The lessons learned from studying these sinkholes can inform strategies for mitigating similar risks worldwide, fostering a more comprehensive global understanding of permafrost instability and its consequences. This broader context emphasizes the interconnectedness of our planet's ecosystems and underscores the need for proactive global measures to address climate change before more catastrophic events unfold. Siberian sinkholes driven by thawing permafrost highlight climate change's devastating impact. This necessitates urgent action to understand and mitigate future risks. In your opinion, what collaborative international efforts are needed to address this global threat? Share your thoughts in the comments.